So why should we implement passive nodes? The role of the passive node is to monitor the availability of the active node and the service provided by the node. If they are unavailable, the passive node activates. This requires at least two computers, the active and passive nodes, to be connected. They need to share a local area network which is dedicated to checking the availability of the two nodes. Best practices show that an active node availability test is of key importance for the entire failover cluster. Knowing this, you shouldn't use a public web interface for the purpose. If the active node was a file server that receives and sends huge amounts of data, it might not be able to answer an availability query in time. As a consequence, the service would fail over to the passive node, which is of course something we wouldn't want. Other than the active and passive nodes, there are also shared resources in a service failover cluster. This is a location to which an active node saves changes in its configuration. This implies that it's not enough to have two computers and a system that supports clustering. A service that is protected with these measures must also support clustering. It has to log all changes in configuration in quorum files. The changes are asynchronous, which means they occur only in one active node. This explains why if there's a fail and a failover following a change in settings, the passive node might not acknowledge and implement the changes. This could lead to a system inconsistency. The quorum, which only the active node can access, is capable of synchronizing both services. Imagine that because of a virus, a detected intrusion, or a simple failure, we need to shut down a computer or stop running a service. What can be done to restore the services? There are a few options to choose from. The first solution, which is also the safest and most recommended option, is reinstallation. The drawback of reinstallation is that it is unfortunately also the most time-consuming solution. To reinstall a system, we need to use disks that we've checked and are sure they have not been modified. We need to erase data from all hard disks of a compromised computer. We have to do this because we're not sure whether or not the files have been modified. It's far easier to delete all data and reinstall the system than find one modified file. The second option is recovering a computer system and installed services from backups. To be able to recover a system, we need to have made backups on a regular basis. The strategy for creating backup copies will be covered later. The files that are saved in those backups have to be trustworthy. We need to be fully sure that the copy has been made before an attack from which we're recovering took place. Otherwise, recovering files from a backup doesn't make sense. This suggests that it's necessary to keep more than one backup of your infrastructure.